want to welcome everybody to the April Novice meeting. My name is Chris Morisette. I'm the Novice Chair for the Houston Astronomical Society, and I'm glad you could make it tonight. We will be recording the presentation, so if in the future you want to go back and look at this fascinating topic, you'll have that ability. As I'm going through the presentation, I will ask if you would to please go ahead and put your questions in the chat functionality of Zoom. And then at the end of the presentation, I'll come back and pick up those questions. So that way we can, I'm kind of a one-man show tonight. So that way I can come back and get to the questions. All right. So without further ado, let me jump in here. So galaxy season is here. And what we're going to be talking about tonight is navigating the spring sky. So the topics for tonight are going to be talking about some methods and resources that you could use to navigate the spring sky. We're going to talk about the Big Dipper as our signpost. You may remember from the winter discussion, Orion was our signpost, and that's going to be going down over the horizon soon. So the Big Dipper will now be our signpost. And it will take us a tour of the spring sky, look at some really cool objects that we will have access to during the course of the spring months. We will then talk about some celestial events coming up in addition to the solar eclipse. And then I'll say a few words about the Novice Lab here at the end. You notice I have that marked as postponed, and I'll say more when we get to that point in the presentation. Okay, so let's talk about navigating the night sky. So we have at our access phone apps, we have go-to mounts, and those are really great technologies to have. But it always is a great idea to be able to navigate the night sky naked eye on our own without any aids, such as an app or a go-to mount. It can come in handy because sometimes you just don't have access to a cell signal or a piece of equipment that you would need. And then there's also a certain amount of accomplishment and enjoyment in learning the night sky on your own. So that's my encouragement tonight. Certainly use the apps. They're a great learning tool, but use them so that you can get to a point where you can navigate on your own. In addition to, the apps and the go-to mounts, there are some other classic materials that are out there that'll help you better understand the night sky, better understand the stars, and help you when you get out there to actually star hop on your own. You'll see shown here in this slide some various references, Pocket Sky Atlas being prominent among them. These are very detailed atlases and references that you can use to better learn the night sky and better prepare for a night out under the stars. When I first started out, I got Turning Left at Orion, which was a good reference, but I really didn't appreciate it until I stepped back a couple of steps and did some more learning and navigating on my own to really appreciate what those were all about. So, but they are available, and I just wanted to make you aware of those. Again, the Pocket Sky Atlas is one of the more popular references that are out there. And the message that I want to give you here with respect to navigating the night sky is that what you really want to do is you want to learn those constellations. And the constellations, for those that are new to astronomy, that's really a region of the sky, a pattern of stars that make up a particular constellation. You may hear the term asterism as well. The Big Dipper is an asterism, but it's a subset, if you will, of Ursa Major, which is the larger pattern of stars which make up a constellation. But learning the constellations is really your first step in being able to learn the night sky. One thing that I latched on to early on was sometimes I had a hard time seeing the patterns that were out there in the night sky. So what I began to do is I began to, be able to identify the bright stars that are up in the night sky. And what you see here are a picture of the 24 brightest stars. I guess it's 24. Let me, 5 times 5 is 25. 25 of the brightest stars in the night sky. And I put a kind of a gray patch over those stars that are really uh, more southern hemisphere. You can only see them down there, and they are really what you use when you're star hopping down in the southern hemisphere. But the ones that are uncovered are the ones that you can really utilize um, in the northern hemisphere. So the reason I bring this up is if you can identify these bright stars, you can get in the neighborhood of a constellation, and then from there you can study it more closely to pick up on the pattern. Orion is a really great constellation to learn at the very beginning because it's in the winter. The sky is usually pretty clear and crisp, and the stars are very bright. It has, if you look on the chart here, it has Rigel and Betelgeuse. Those are two of the brightest stars in the night sky, and they're both in Orion. So, being able to find a bright star, and then from that star, being able to pick out the other stars in the constellation, yeah, it's just a kind of a tip to help you along your way. Again, for those new to astronomy, I'll just mention a couple of other references. There's a children's author called H.A. Rey, who wrote the book Curious George. And H.A. Rey put together a couple of really nice books called Find the Constellations and the Stars. And what H.A. Rey did is he, in his Find the Constellations, he actually took the traditional connection of the stars, if you will, that kind of showed that mythical pattern, and he changed the segments and how the connection between the stars appeared. And I think the best example of what he did to kind of make things more uh, graspable or usable is down here in the whale constellation. You see over here on the left is kind of the typical fiction that you would see in a reference or star atlas. And it's kind of tough to tell if that's a whale or not. Well, just by changing the connection points, not changing the star pattern, but just changing the connection points, he made a figure that looks much more recognizable as a whale. And he's done this throughout the, various other constellations as well. Again, these are children's books, but, they're really meant for anybody that's just starting out in astronomy. So I encourage you to look into those if you want to learn more about picking out patterns for constellations and learning some of the basics. Here's one of my favorites. If you were at the Winter Novice Lab, I brought a copy of this out and we looked and went over it in detail with the participants. But what you see here is is kind of a miniature sky atlas or star reference. Folds up into the size of a gas station map, but it's just chock full of information. The front up here, it shows shows a map of the cosmos and has all of the constellations on it that we could see here in the northern hemisphere. It has a long list of the famous and even more obscure deep sky objects. And it is just a wonderful map to kind of pull out and study, kind of ad hoc, just easy to use, has a lot of information. On the back, you have the table. It has various information about each of the deep sky objects on the front of the map. Again, I can't say enough good things about it. It's only 15 or 16 bucks, so you really can't go wrong with the price. So that's one other reference that you can utilize. Planispheres are great. I don't know if any of you out there have used one of these, but it's really a great tool to allow you to, depending on the time and date of the year, to kind of dial that in and get a picture of what uh, the night sky, what constellations are up and available to us in the night sky. Uh, Both astronomy and sky and telescope also have some, great information, monthly star charts that will cover any particular month. That is another great resource. And then one that I really like a lot are these free maps from skymap.com. What you see here is this the front page, I think of a 2 or 3 page download that you can get for free. And in addition to getting a picture of the night sky, which you see in the circle here in the middle, you've got a nice listing of things that are going on during the course of the month. So that is really cool. So in looking at the map, what you're looking at here is a picture of the night sky as we're facing south. So you notice that south is on the bottom. And this would be the picture of the night sky that you would see roughly 10 o'clock in the early part of April, and later on in April, this would really be what you would see at around 9 o'clock p.m. And so, standing south with look facing south with the map, if it's south down at the bottom of the page, you can see the various constellations. So you see Virgo up here, Leo, Cancer, Gemini, so on and so forth. And you'll notice over here that Orion is darn near down below the horizon by, 10 o'clock, 9 o'clock during the month. If you want to face north, then all you need to do is turn around and face north, and then turn the map upside down, and that'll give you a picture of the constellations that you'll be seeing in the northern sky. You'll notice here the Big Dipper, which is part of Ursa Major, is way high up in the sky, which is allows us to use it as a tool to navigate, which we'll talk about a little bit more. So it's a great reference. It's free, and I encourage you to check it out. So with that, I'm going to just kind of go back through and talk about some of the basics that we talk about each quarter when we go and do our quarterly sky tour. If you remember from the winter talk, we use a model called the celestial sphere, which is really a sphere of stars that surrounds Earth. And we also have, as part of that sphere, a celestial North Pole and a celestial equator. And that's essentially the same North Pole and the same equator that Earth has. It's just projected out into the heavens. There's also this other elliptical orbit, if you see pathway here, called the ecliptic, and that's where the sun and the planets reside, the moon as well. If you want to find a particular deep sky object or star, you want to use a coordinate system called right ascension and declination. So, in that Deep Map 600 chart that I showed you earlier, on that long table, you get the right ascension and declination coordinates for each of the items that are on the map side of the reference. And if you use those two coordinates, you can find that object on the map. Right ascension is analogous to longitude, and declination is analogous to latitude on a terrestrial map. So that's what we've got going on with these with this coordinate system. So again, and they'll never change. They're always the same. Unlike altitude and azimuth, which change constantly. These are fixed in space. Here's another view of the celestial sphere. You see here the ecliptic, which is the red equatorial band, or the red circle that you see right here. One thing I did want to mention is that the constellations that fall along the ecliptic are referred to as the zodiac constellations. So Cancer, Leo, Sagittarius, Taurus, those are all constellations that are, well known in astrology, but in astronomy, those are the constellations that fall along the ecliptic. A little bit about the apparent motion of the stars, and it's going to depend on the latitude that you are at. So if you are at the North Pole, the celestial North Pole and Polaris, which is our North Star, will be right above your head. And as the night goes by, the various objects in the sky, the stars anyway, will appear to circle around your head. And that's because you're at 90 degrees north. As you move farther south, things change and you get the sphere appearing to rotate more around us, like the sun would, for example. So in the picture on the right, Houston is at roughly 29 degrees north, which means Polaris will be at 29 degrees above the horizon. The axis of rotation of that sphere, that imaginary sphere, will be around this point from yourself up to Polaris. So you'll see the Big Dipper indicator coming up and around and then down over the horizon. And that's going to be, for the most part, the large majority of the stars and constellations that you'll see at night. Now, there are some stars and some constellations that they call circumpolar, meaning that they will never go down below the horizon. And I think on the next chart I show some of those, but you can see in this picture what's happening. And I apologize for fidgeting around with my mouthpiece, but this microphone is a little bit close to my mouth. In any event, you can see that Polaris is the dot in the center, but the stars that are in and around that, within 29 degrees, because I think this was shot out in West Texas, which is roughly the same. It can be roughly the same latitude as we are here in Houston. Those stars will never go down below the horizon. They will disappear during the day, not because they're below the horizon, but because the sun is so bright that it's blotting those out. But this picture kind of demonstrates circumpolar and also kind of gives you a feel for what that celestial sphere is all about. In doing our in navigating the night sky, again, knowing where Polaris is really key, because that's kind of where a lot of things start. A lot of things are kind of centered around. So being able to find Polaris is a great idea, and it's very easy to find. You actually just go off of the two stars that are on the end of the cup of the Big Dipper, follow that up, and you'll hit Polaris. So very easy to find. And then if you want something a little less complicated, you can always get out the flag of Alaska, and they have exactly the same situation here. So here again are the two stars on the end of the cup, and if you follow those up towards the top of the cup out, you'll end up at Polaris. So a little bit of navigation, rudimentary navigation here in finding Polaris. I mentioned earlier that the Big Dipper will be our signpost. Here's kind of the reason for that. If you look here, we're in the springtime, and this picture of these four boxes that you see here is what you would see 9, 10 o'clock at night during the course of April. You'll notice that the Big Dipper is high up in the sky here, and because it's high up in the sky, we're able to utilize it. And in particular, we're able to come off the handle and get to some other stars that I'll point out to you here shortly. In the summertime, it is still useful. It's still high up in the sky. We can use it for some of the evening, not all of the evening, but for the most part, prime time viewing during the evening. And then when we get down here to autumn and winter, it's not so useful. So in autumn, the Big Dipper is really down close to the horizon during the nighttime, which really won't allow us to look at much. And that's the same story that we have in the winter. So that's just to kind of give you an idea of why the Big Dipper is useful now, but not necessarily useful later on. We'll utilize other signposts during the summer, fall, and in the winter. We talked about circumpolar stars and constellations earlier. If you look here, here's Polaris, and then moving out 30 degrees, you'll see within this band here, this circle here, these are all the things that will be circumpolar here in Houston. Cassiopeia, some of those stars will stay above the horizon, but some go down below. So there's really not a full constel other than Ursa Minor, which is where Polaris resides. None of the other constellations in total will stay above the horizon here in Houston. Now, if you go farther out, say if you go out 45 degrees, which would be the latitude that you'd find, up in the northern states like Minnesota or Washington State or Montana, there you will see whole constellations that will stay above the horizon for its entirety and not go down below the horizon. Another thing that I wanted to talk about briefly as well is precession. So, we have a North Star now by virtue of the tilt or the position of the tilt of the Earth. But the tilt of the Earth, the top here of the Earth actually follows a long precessional circle that you see here. And this is really illustrated well by this pop that you see here. That circle that it's making up at the top is called the precessional circle. And so our Earth does the same thing. And what you'll see here is Polaris, but one revolution around this circle takes about 26,000 years, excuse me. So here we're at Polaris, but in about 13,000 years, Vega will be our North Star. So that changes over time. And that's why. It's because the Earth is actually moving in a precession. The north and south pole of the Earth is moving in a precessional, making a precessional movement. The Earth also does another thing too. It does this thing called a nutation. So in addition to making this circle, it's also squiggling in and out like you see here. And that squiggle happens in a relatively short time period. 30 years is about the time that can go by before a lot of the references need to be updated. This nutation that you see here is the result of the pull and push and pull of the Earth and the Moon. And so that's why we have this squiggle in our precessional circle as well. So I mentioned earlier that, star charts need to be updated. Here's a picture of a atlas that was built for the 1920 to 1950 time period. I think the last time the star charts, etc., were updated was in the year 2000. So we're probably due for a big overhaul, at least in the printed versions, in 2030. Now, as we've gone more electronic with everything, that need probably is not as urgent as it used to be. As a matter of fact, I would venture to guess that apps that you have on your phone are probably updated on a very frequent basis. You take that take that into account. I may be wrong, but that's kind of the way of the world now with electronic information. One last thing I wanted to leave you with here on the methods and resources is just a simple way that you can measure distances on your own while you're out under the stars. So if you put your hand at arm's length and you put up a pinky and you look at the width of that pinky, that measures 1 degree. 3 fingers will be 5 degrees. This will be 10 degrees. Hook'em horns will be 15, and then pinky to thumb is going to be 25. So if you hold that out at arm's length, you go up into the sky and you use the distance between, say, your pinky and thumb, you can measure 25 degrees from one object to another in the night sky. So again, it's just another way for you to be self-sufficient out there under the stars. Okay, so we've talked about resources and methods. Now we're going to really dig into some of the meat. And before we do, excuse me just a second. Oh, thank you. Get a nice drink of water. Keep everything lubricated here. So we're going to talk about the Big Dipper signpost. So let's get into that. So you remember Orion was our star of the show, pardon the pun, back in the winter. Now we've moved to a different part of the night sky. So this green box that you see here really represents kind of the prime time viewing area, if in general terms of the spring season. And so you'll see that Orion is no longer of any use to us, but the Big Dipper, along with two bright stars called Arcturus and Spica, we can utilize to navigate around and find various constellations, like Leo, like Virgo, which are going to be two prominent ones that we're going to find. And once you get into that neck of the woods, you can find some bordering constellations real easy. But Leo and Virgo have a lot of neat stuff in them. So being able to get to those is going to be a really nice feature of the signpost. So here's kind of what the Big Dipper looks like to us in the night sky. It's high up in the sky. And then here's a picture that kind of gives you some indication of how we can use this. So we talked earlier about using the end of the cup to get up here to Polaris. You can also use the inside of the cup, the two stars on the inside of the cup, to navigate down to Regulus, which is the bright star in Leo. And again, going back to the method that I talked about earlier, if you can find Regulus, then you have a fighting chance of figuring out the rest of Leo. Over here on the left, what you can do off of the handle of the Big Dipper is you can do something called arc to Arcturus. And when I arc to Arcturus, what I'm doing is I'm actually coming off the handle of the Big Dipper and I'm following down here to a bright star that's reddish in color. And Arcturus is in the constellation of Bootes. Now, there are some cool things in Bootes that we'll be looking at. But once we get to Arcturus, then we can spike on to Spica, which is the main bright star in the constellation of Virgo. And Virgo is where a lot of cool stuff is. So by utilizing the Big Dipper, arcing to Arcturus, and spiking to Spica, we can find our way around at the relevant points in the night sky, in the springtime night sky. All right. I'm going to take one more drink before I start in on this. Excuse me. Thank you. So now let's dig in and talk about the spring sky. But before we do, I mentioned earlier that's galaxy season. I wanted to explain a little bit about why that's so. Here's one of my favorite pictures. I think I've used this in many of the talks I've made. But what you see here is the solar system, and it's positioned in the galactic disk of the Milky Way. Obviously, this is not to scale. The solar system is just a fraction of a light year in size, and the width of the galactic disk is probably, I don't know, 15 to 30,000 light years in thickness. So it's not to scale, but what we are in a position here during the spring equinox where we are looking through kind of we have our thinnest view out from the Milky Way out into deep space. So kind of like when you are in your driveway and you look up above your head through the zenith, you're looking through the least amount of atmosphere on our Earth. It's kind of the same thing here. We're looking through the least amount of the disk of the Milky Way as we would, at any other, at least during the summer and the winter for sure. Okay, so that's one reason why it's galaxy season. But the other reason is when we're in that position, we're also looking out towards some very galaxy-rich areas, and the Virgo cluster being probably the most prime example of that. So there are a ton of galaxies right here and over here in Leo, and just generally in this part of the sky. So, by virtue of our position relative to the Milky Way, and by virtue of the direction we're facing, and all of the galaxies that are out there, that's why we're in galaxy season. All right, so with that, let's go ahead and start finding some of the targets that should be on your list for this time of year. I'll start out with an easy one. We're going to do a double star called Alcor and Mizar, and so this is a really easy one to find. It's right. It's the middle star in the Big Dipper handle is actually a double star. So if you are looking up in the sky at the Big Dipper and you have a pair of binoculars for sure, look at that middle star and you'll be able to resolve two stars that are relatively close together. That's Alcor and Mizar. So that's a great way to start because it's an easy one and it'll kind of give you some confidence as you go and look for more of these objects because they can get more difficult for sure. The next one on our list is going to be M51. So let's look at it. Oh, one other thing about Alcor and Mizar. So that's about 82 light years away from Earth. So it's a very close object to us. And as I mentioned earlier, it is in the Big Dipper, which makes it part of Ursa Major. All right. So M51 is a spiral galaxy, and it is 3.5 degrees below the Big Dipper handle. So if you measure 3 fingers, which is 5 degrees, and that'll get you close to where M51 would lie right off the Big Dipper handle. And so let's take a look at that. You can see M51 here, and it actually has a companion galaxy, NGC 5195, the smaller galaxy over here. This galaxy is about 28 million light years away from us, and it's about 112,000 light years in size. So it's roughly the same size as our own Milky Way. The cool thing about this galaxy, it shows you a really vivid example of how galaxies will interact with each other. When I first got involved in astronomy, I thought that was such an unusual thing. Turns out it's a very common thing. Galaxies do travel through space, they interact with other galaxies, and when they do, changes occur. In this case, it looks like part of the galactic disk off of the small galaxy here is being drawn into the larger galaxy. Our own Milky Way eventually will run into Andromeda, which will yield a whole completely new and different galaxy. And when that's all said and done, that's a good 4 billion years away. So nothing we need to worry about now. But anyway, this shows you a really vivid example of how two galaxies can interact, and that's M51. The next one I wanted to show you is M101. That's another galaxy up here, and that's about 5 degrees above the Big Dipper handle. So again, 3 fingers. If you measure kind of an isosceles triangle, you measure with your 3 fingers 5 degrees. That'll get you up into this neighborhood of the galaxy. That's where you would find M101. One thing I want to be sure I make clear during this talk, I make it sound very easy to find these objects. Okay, it's not that it can be more difficult, and that's why the novice labs are such a great way to really get your hands dirty finding this stuff. When we did the winter lab, we had some easy ones that we could go after because you could see them naked eye. But when you got into the ones that were more obscure and more difficult to see, it got a little bit trickier. So while I'm breezing through it here in the presentation, I really want to impress upon you that getting out there and practicing and finding these things is really the way to build proficiency. And anyway, that just wanted to make sure that was clear. But with that said, let's talk about M101. Again, 5 degrees above the handle here on the Big Dipper. And here is a picture of M101 by our own Jeff Lepp. Beautiful rendering of M101. Again, it's a spiral galaxy. This one is in let me see what I think this is in Ursa Major. M51 was actually in Canes Venatici, which is a bordering constellation. I forgot to mention that. But M101, I believe, is in Ursa Major. It's about 23 million light years away, and it's a rather large galaxy. It's about 162,000 light years in size. It's 1.5 times the size of our own Milky Way. If you remember last year, there was a supernova that was detected in this region of M101, and that I remember was really neat. Out at the George Observatory, we actually were able to show comparison shots of kind of a before and after, showing that that supernova here. If I'm not mistaken, I believe this image was captured beforehand, although this area right here seems pretty bright. But that was really an unusual event to see a supernova occur, and M101 is where that occurred at. So that's M101, right above the handle of the Big Dipper. Okay, so now what we're going to do is we're going to go out from the top part of the cup of the Big Dipper about 14 degrees that way. And when we do that, we'll get to a pair of galaxies called M81 and M82. So this used to be referred to as Bode's Nebula. And then when they figured it out, it was actually a galaxy. It got renamed Bode's Galaxy. And this is its companion galaxy right here called the Cigar Galaxy, which is M82. These two galaxies are about 12 million light years away. So they're closer than the other two that we looked at. They are about 3/4 the size of the Milky Way here and about 1/3 of the size of the Milky Way here. So they're smaller galaxies, but they're relatively close to each other. And due to the fact that they're so close, you can kind of make out in this picture here of M82 a red crease through the center of this galaxy. That's actually starburst activity. So what you have is, because of this interaction with M81, you have a gravitational effect acting on the galactic disk of M82, which is creating the starburst effect, which is resulting in rapid star formation. So again, another effect, like we saw with M51, material being pulled in from one galaxy to another. Here we have this gravitational effect where the galactic disk is actually being deformed and creating a region of rapid star formation. So again, just another example of galaxy interaction, which I think is so cool to think about. And this is also in Ursa Major as well. And so now let's look, and we're going to pivot just a little bit, and we're going to go look at a globular cluster called M3. So you remember when we arced to Arcturus, we got to this bright star down here at the tail end of a constellation called Bootes. And then right across the border in Canes Venatici is M3. But since we know how to get to Arcturus, we can find our way to M3 because the distance from here to here is about 10 degrees. So you make that fist in the air, put it at arm's length. That will allow you to get into the neighborhood of M3. And when you do, you'll see this, which is a beautiful globular cluster. It's about 32,000 light years away from where we are here in our solar system. Globular clusters are unusual animals. They will actually reside in the halo of the Milky Way, and I'll show you a picture here on the next slide. So they're a little bit unusual in that respect. The other thing too is that there are almost 500,000 stars in this picture that we're looking at that are, gravitationally bound to one another. So you really have a nice, brilliant, compact grouping of stars that is really fascinating to look at. And that's M3, one of many globular clusters out in the cosmos. I mentioned earlier that these stars will reside in the halos, or these clusters rather, will reside up in the halo of the Milky Way. Um, and if you were able to attend a discussion or presentation last fall by Justin McCallum, he talked about globular clusters. If you want to find out more, I think his recording of his presentation is still available on the website. So check it out. But these are roughly where they reside, and they are gravitationally bound to the Milky Way. They will actually orbit around um, the Milky Way, and but they are out here in the halo, so to speak. So that's M3. And now what we're going to do is we're going to get down into kind of you know, the highlight of spring viewing season, and that is really all these galaxies that you see in the Virgo cluster and in and around Virgo and Leo. So our first stop on this is going to be the Virgo cluster, and that's what you see up here. We're going to actually look at a picture of something called the Markarian chain. So Spica, again, when we speed on to Spica or spike to Spica, we get to that very bright star in Virgo. And then once we've gotten there, we can navigate our way around and get up into the Virgo cluster. So let's take a look at that. So what you see here is a picture of a group of galaxies called Markarian's chain. And this is actually a group of galaxies, and I can't point out the exact ones, but it's tucked up into this grouping of galaxies up here, and that's what you're looking at here. So all these items right here, 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 and here, 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 and here, they are all galaxies, all in one shot. And the really interesting thing about Markarian's chain, it's kind of the one object that I've seen photographed by people like you and me in our club that gets us close to understanding what a filament would look like. And a filament is kind of a large cosmic structure where galaxies kind of form. In this case, they call it a chain, but a filament, which is like a thread, a piece, a hair, a piece of rope, whatever you want to call it, that all these galaxies are attached to, gravitationally bound to, expanding out away from, the origin of the universe. And so this is one of the few pictures that kind of give you a feel for what that might look like. Filaments and walls and voids are terms that you find when you talk about, the bigger structure of cosmology. But again, this kind of gives you kind of a starting point to just wrap your head around the concept of what is a filament. Okay, so that's Markarian's chain. This next one is the Sombrero Galaxy, and I'm just going to hop back up real quickly. The Sombrero Galaxy is actually really close to Spica. It's about 7 degrees from Spica, so it's not in the Virgo cluster per se, but it is down in Virgo. So it's a beautiful example of an edge-on galaxy. You can see this beautiful dust lane right here. You can still see the bulge that's inside of the galaxy, although some of it is obscured by the dust lane. This galaxy is about 28 million light years away, and it's about 7/10 the size of our own Milky Way. And it, again, has that beautiful edge-on look and dust lane, which is really a treat to go out and look and find. And so that's M104, the Sombrero Galaxy. Let's switch gears a little bit here and talk about an open cluster. Open clusters are good. Again, it kind of gives us a simpler object to go out and find. And we're going to look at here M44. M44 is an open cluster in Cancer. We didn't talk about getting to Cancer, but we certainly can get to M44 if we know how to get to Regulus. So if we find Regulus over here in Leo, and we go 18 degrees this away, or if we recognize Gemini, which we should have when we were practicing our stargazing back in the winter, we can get to it here by going 12 degrees from Pollux down here, we can get to M44. And here's a picture of M44. It's about 610 light years away from Earth. It is an open star cluster, so it only has about 200 to 350 stars in it. So many fewer than what you'd see in a globular cluster. One story I want to relate to you, if you were with us last year, I talked about astronomy from New Zealand. I just gotten back from New Zealand went there last March. Um, I took some pictures when I was down there. One thing that really puzzled me is I picked up in one of my pictures an open cluster that I just couldn't identify. I was facing north at the time, and for one reason or another, I just couldn't figure it out. So when I got home, I kind of went back on Sky Safari and I re-engineered, my location, my direction, or the direction I was pointing, and lo and behold, M44 showed up. And the reason that I didn't snap to it right away was because when I'm here in Houston in the Northern Hemisphere, I usually will see this if I'm facing south. Down there, I was facing north and I didn't recognize it. But once I, figured out, okay, you're in the Southern Hemisphere, facing north made sense. So I thought that was an interesting story because if you've ever been down to the Southern Hemisphere, things get changed up a lot. And that was one example of where I got lost, but I was able to kind of figure it out after the fact. So anyway, that's M44. And again, a great target to start out early on when you're doing your stargazing and finding these targets. Okay, so we're going to wrap up here with Leo. And again, we can get down to Leo. We can find Regulus, which I think is this bottom star right here in the Lion. Maybe it's this one here. I can't remember. Let me go back up and look real quick. Regulus is down here at I think in the bottom part of the guy. Anyway, I can't tell exactly. I should know this too, and I'm the novice chair, but that's okay. That just shows you I'm a novice, just like everybody else. Okay, so if you can get to Regulus, you can find these galaxies. This is a pair of the galaxies. I think M65 is this one here. M66 is this one here. And you can find these galaxies by going 12 degrees over from Regulus. And that's how you would find the Leo triplet. Now, here's the fuller picture of the triplet. So these are 3 galaxies in Leo. I was fortunate to be able to photograph this last year. It was a difficult evening with clouds moving in and out, but long and short of it is I was able to capture it. This one right here is a really cool galaxy. This is NGC 3628. Again, it's an edge-on galaxy, just like the Sombrero galaxy, but here the dust lane obscures most, if not all, of the glow of the central bulge of the galaxy. So really a cool grouping of galaxies. These are all roughly 40 million light years away, and they're all roughly the size of our own Milky Way. So that's the Leo triplet. So here you see a summary of the objects that we've looked at in our sky tour. I like to put this table together at the end so that you can use this as your target list. Obviously, you're not limited to this, but this will give you some ideas on items to go out, objects to go out and look at. Over here in the right hand column, I have here viewing options, what kind of equipment you would need, or you can do it naked eye, binocular, so on and so forth. So these items, this table right here, hopefully can provide to you kind of a way to get started in going out and doing your own stargazing. And again, don't limit yourself to these. If you see something else that you're really interested in, by all means, go for it. All right, so that's kind of a summary. And also, these are the types of targets that, like for the winter lab, I brought this list was kind of our objective for the evening. So the items that were on the list, we went out and found and looked at. We didn't get them all. We had a full moon we had to contend with. But that's kind of the idea behind this. So in addition to stargazing, we have some upcoming celestial events. Not sure if you've heard, but we're having a solar eclipse here on Monday the 8th. If you don't have plans to go out to the hill country to look at this, the Houston Museum of Natural Science in Sugar Land is putting on a viewing event. This event is from 10 a.m. to 3 p.m. on Monday. The admission is $15 and 10 for members. The website here at the bottom gives you the place where you can get tickets. Here is where you can get more information on the event. I'll be out there volunteering myself, so if you come on out, stop by and say hi. I don't know what the weather's going to be like. Everything I've seen in the forecast is not real good. So I know that they have plans to bring in a live feed from other parts of the country where the weather is acceptable, is good for viewing the eclipse. So it's kind of a consolation prize, if you will. I think also the McDonald Observatory is doing something similar on YouTube. I don't have that information handy, but if you go onto YouTube and type in McDonald Observatory, you can probably find it. Meteor showers. There are a couple of meteor showers that are happening this month. The Lyrid meteor shower, which is radiant between Hercules and Lyra, and that is active between April 14th and the 30th. The Eta Equinox, which is radiant between Aquarius and Pegasus, is active between the 15th of April and the 27th of May. And then we have a couple of close encounters here that are worth mentioning. The Moon, Mars, and Saturn will be within a 3-degree circle of each other in the morning sky. April 6th is when that's supposed to occur, which is here in a couple of days. And then on April 10th, the Moon, Jupiter are going to be close to in the evening sky. And again, that happens on April 10th. So those are some additional events that are going on. One thing that I wanted to wrap up with was just a discussion about the novice lab. Unfortunately, I have to cancel or postpone the novice lab that we're going to have for the spring. I've got a medical procedure coming up on April 15th, and from what the doctors tell me, it's not something that I'll recover in time to get out there and lead this effort. I got lifting restrictions, things like that. So I'd have a hard time dealing with that in the April-May timeframe. June, July, and August, I'm going to be traveling. So I really think the next time I could probably pull one of these together, possibly in July, third quarter, or September. But for sure, I'm going to try to target for the fourth quarter. Again, we won't be looking at the objects that we talked about here tonight. We'll have a whole new set of objects, but I really want to make a point to hold these labs because I think they're so important to help people really learn how to navigate the night sky. So more to come on this, and when we can, we'll certainly get one scheduled. So with that, I just want to encourage you all to get out there and stargaze. And I also want to remind you about tomorrow night's presentation, Great Eclipses of History by Don Stelly. That'll be our general topic tomorrow night at 7 o'clock. So that is that. And with that, I'm going to open things up, and let me see. Chat. Let me open up the chat here. Okay, thanks for the great presentation. You bet. Let's see what else. Will you identify the power of scopes you need to see the items you have shown us tonight? Yeah, that is a good question. And that's by let's see, that's by Peter. So Peter, let me go back up a couple of slides. Let me go. Let me go here to my chart. Yeah, I'm really kind of cagey about that because I don't have a focal length identified. What I'm trying to say here is if you have telescopes like small telescopes that are in the like a refractor that's 4 inch or less, or in the large telescopes where you're greater than 5 inches in diameter. I'm really talking about a Dobbs. Um, I know those can come in different focal lengths. I've got a 10-inch Dobbs here, and let me just do something really quick. I don't know if I can tell. I can't read it from here, but I think the focal length on this 10-inch was about 1,000 millimeters, and I think we calculated that. Well, I'm doing math in my head, which is dangerous. Um, but if you think about a large telescope, think about a Dobbs. And if you go and you find a 6 inch Dobbs or an 8 inch Dobbs or a 10 inch Dobbs and look at the nameplate there, they typically have about the same focal length. But that's an unsatisfactory answer. Just give me 1 second. Hang on just a minute. I'm back. Yeah, so the focal length on that was 1,200, and the ID is 10 inches. So if I have a 25 millimeter eyepiece, I'll have I'll have a magnification of around 48, so 48 or 50, and that was what we used at the winter lab, and we were able to find the smaller, more obscure items. As a matter of fact, in some cases, the uh, field of view for the Dobbs was too small. So binoculars really worked well there. But for these galaxies, something like that is definitely going to be, something that you'll need. Did I answer your question, Peter?
Yeah, pretty much. I mean, I just all I've got right now are binoculars, and I've got a friend that has a small Dobsonian, and so I hope I'll be able to borrow that. But the only one of those things that I saw tonight that I've seen uh, the beehive cluster
Right.
with my binoculars,
Right.
and but I haven't seen any of the. I've tried to find some of the galaxies, but I don't think a 25 by 70 binocular is going to be able to pick them out too well.
Right. I think, yeah, so the only galaxy that I found a naked eye actually, but with binoculars, it looked beautiful as Andromeda. But that's a kind of a different beast because it's so close. These galaxies that we looked at tonight, you're going to need a large telescope. You're going to need something like this 8 or 10 inch Dobbs that I've got here in my living room, because you just need to have the magnification and the ability to collect the light, because these things are pretty faint objects.
Yeah, yeah. And the other thing is, what do you mean by electronically assisted astronomy?
Yeah. So, great question. Before the Sea Star came out, I got into astrophotography, and what I have is a small refractor with a camera. Okay. And with this small 2 inch refractor with a camera and a piece of software called SharpCap, I've been able to go out and find, like, for example, the picture that I showed you earlier of the two galaxies, Bode's galaxies. Let me hop back up to that real quick, if I can. Let me. So this is a picture, but you could also make this show up using electronically assisted astronomy, which is basically just using a camera and SharpCap to take a sequence of take a sequence of 10-second images and stack them. All right, so that's what you're doing here. So this picture here, I don't know if you can see it on the screen, but this M81, M82 is what I actually took with a 2-inch telescope. All right, you know, very small. It's almost like a glorified telephoto lens. So, but that's what I'm talking about with EAA is using a telescope with a camera and some software. Typically, this software called SharpCap, and then what you're doing is you're taking a series of images, and then what you're doing is you're stacking those, and you're creating one composite image. So what you're doing is you're enhancing the signal, and that's how you're able to see these really faint images in the using, like I said, electronically assisted astronomy. So that's what I'm talking about.
They call that Sharp's cap, huh?
A sharp cap.
Sharp cap.
Yes. Huh. And so you have probably noticed on some of the email strings going back and forth, people talking about the C-Star, that new telescope that's got everybody in a buzz. That's an example of where you're able to see these more obscure objects by using electronically assisted astronomy. Now they were able to actually get a picture out of it, but that's what they're doing with those, and those are much easier to use than the system that I've cobbled together. So anyway, that's what we're talking about with electronically assisted astronomy.
Okay. Well, thank you very much for your work tonight. I appreciate it.
You're welcome. I have here from Chris Menon. When is the Perseids showers? I don't know. I will have to find out. I want to say they were back in January, but if I did, I'd be lying to you. So I don't know. I don't know, Chris, unfortunately.
Okay, that's fine.
Is that okay?
Thank you, sir.
I know just a simple query on Google will give you your answer there. So I'm sorry.
Okay, I'll do that.
Okay,
thank you.
Fantastic. Okay, Chris asked, would you provide a brief summary of how well your group did at the last lab using binoculars versus telescopes listed? Okay, appreciate that. And before I answer, did you have anything to add to that, Chris?
Not really. Other than I really like binoculars a great deal. I have multiple telescopes, but about I don't know, a year and a half ago, I got some ADMs, 12 by 56s. They're just super clear glass, really nice, and I have a lot of fun with them. So I'm using binoculars a great deal, and this wasn't able to make the lab, unfortunately, and thought your conditions were probably pretty good that night, and just wondered how some of the guys did.
Yeah, no, that's excellent question. So we had our lab at the end of February. We had a rather bright moon to contend with, so there were some star clusters in Auriga that we just couldn't find. But we were able to use binoculars for quite a number of those objects. So the Orion Nebula, M42, M45, which actually shows up the best in a pair of binoculars. The triple double in Hades in Taurus. The star clusters, when we got to the star clusters, we pretty much reverted to like the 10-inch Dobbs. I know a couple of the guys that were there in the group that were helping out had some smaller telescopes. Matt Borlange, he had almost like a hunting scope that he had out there. I want to say it was like maybe a 2 or 3 inch scope refractor that worked really well for some of the star clusters. So and we also had an opportunity to look at Andromeda. which we were able to do both with binoculars and, with the 10-inch Dobbs. I know another guy had I think an 8-inch Dobbs or a 12-inch. I can't remember which. But to answer your question, you were able to see a lot of objects with binoculars in that particular list. And then we had some of the smaller objects that we needed to go to the big telescopes with. Now, spring is going to be a little bit different because here we're looking at a lot of small, faint objects. So let me get my table back up. There we go. And so what you see on this list here, any of these galaxies, you're going to need anything from probably an 8-inch Dobbs and greater. You really have a fighting chance at seeing these galaxies. Doing this just straight visual with no electronic assistance. And that was that's why the lab is so nice, is because, a lot of us don't have access to that equipment. So others that have it and have the knowledge to star hop, it's great because they can come in and help us not only have the equipment necessary to see the thing, but also the equipment necessary, also the knowledge necessary to navigate to the thing. So the larger telescope, I get, but just to kind of wrap it up here in my mind, on this question, the larger telescopes are what you're going to need.
Okay, thank you very much.
You bet. Let me scroll down here. James Mayo asked, what are examples of EAA? Did I answer that, James, in my previous dissertation, or was there anything else you wanted to ask? James, are you there? Okay, that's okay. Yeah, Chris, you want to mention SIG? Oh, yes, really good. So there are a couple of there's a special interest group that HAS has called the SIG for EAA. That is run by I think his name is Carlos Abreu, if I'm not mistaken, and they have a meeting once every month on a Wednesday. So if you're interested in EAA, finding more about that, reach out to Carlos and ask to join those meetings. They're really good. If you really want to hone your skills on visual, Stephen Jones, president of our club, is the leader of the visual special interest group. So what you would get with Stephen, I think, is more information and knowledge about how to find these objects like we do at our novice. So that is one thing that I think you'll get from the visual group. But they're both great groups, and I encourage you to look into it and find out more. So, and let's see. Okay, Martel Luther says that the Perseids are in August. So there is the answer to the question. Thank you very much for looking that up and posting it. I appreciate that. Okay, that's all I see in the chat. If anybody has any other questions or comments, feel free to come off mute and go ahead and ask. And if you don't, that's fine too. I'll just kind of give it a auctioneers going once, going twice.
Just wishing you good luck with your medical procedure, Chris, and hopefully you'll have a speedy recovery.
Yeah, well, it's a hernia.
Yeah,
and I haven't dealt with that before, and I thought it would be pretty straightforward. I remember my son having it, but I went into the doctor on Tuesday, and it's a little bit more than I had envisioned. So rather than get everybody's hopes up, I thought I'd just come clean right up front, and then make a full full recovery so that in the summer or this fall we can do one of these. So I appreciate your kind words there, Chris. Thank you. Okay, so I think we're done, and I appreciate everybody coming out tonight. And the recording of this will be available for viewing later on. If you have any questions or comments. With that, I thank you for your attention, and I wish you all a pleasant evening. Thank you.